So we've talked about these tipping points individually, like the Arctic sea ice, like the Amazon forest, like the Atlantic circulation. But the interesting thing is they don't operate independently. So think of it like a domino. Think of each of these tipping points as a domino, and you just nudge the domino a bit, it's okay, and you push it too far and it falls over. If you have these dominoes out randomly, they act independently. But in fact, in the Earth system, they are not independent. Think of a row of dominoes. So you push the first one of the first couple, and they start tipping, affecting the next one and the next one and the next one. A good example of that is the one we talked about a little earlier. So we look at three tipping elements we talked about individually: the Arctic sea ice, the North Atlantic circulation, and the Amazon forest. And we put another one in there, which is the big Greenland ice sheet. That's the big massive ice which sits on the island of Greenland. Now that is an enormous amount of ice. If you melted it all, sea level would rise about 7 meters and flood most of the world's large coastal cities. And also, it's a very high ice sheet, so it's stacked up 2 or 3 kilometers above sea level, which means it's up high in the atmosphere where it's colder. So think of when you go on a hike or a walk up a big mountain, and as you go up the mountain, it gets colder and colder, naturally, because the atmosphere is cooler as you go up. When you come back down, it gets warmer. So here's the thing with the Greenland ice sheet. It's starting to melt because it's getting warmer up in the northern high latitudes, about double the rate of the global average temperature increase. That means that it's starting to melt on top. But just like walking down a mountain, as you start melting, the ice is coming down, and it's coming down into a warmer atmosphere. That means it melts even more, which means it comes down even lower. So you see the feedback again. But then the issue here is that where does that water go? Well, it runs off the ice sheet. And as it runs off the ice sheet, most of it goes into the North Atlantic Ocean. And because it's fresh water, it sits on top of the denser salt water. That has the effect of slowing that north-south circulation in the Atlantic Ocean that connects the North Pole and the South Pole. But along the way, it affects the Amazon forest because half of the Amazon's rainfall comes from the Atlantic Ocean. And as that circulation slows, rainfall is dropping off. At the same time, the present Brazilian government is opening up the Amazon to more deforestation. So now you have a double whammy. You have less forest because it's being cleared for cattle and soya, and that means less recycled rainfall, and you have a slower Atlantic Ocean circulation, which means less rainfall coming in from the ocean. That double whammy is pushing the Amazon rainforest very close to a tipping point, beyond which it will burn and deforest itself, turning into a savanna or a woodland ecosystem. Experts think we're within 5 years of that tipping point. So that's a good example of how these operate as a cascade.